Hello and welcome to lesson 5L. I can find the surface area and volume of solids. All right, guys, this should be review for middle school, but we're going to go through it together so you guys feel okay with it. This was on your summer packet, but again, we're just going to walk through it together. Surface area is the sum of the area of each surface of a figure. There are formulas for surface area, which I am going to use today, but you can always find the surface area just by finding the area of each surface of each side and adding them all together. So prisms and cylinders have basically the same surface area formula and the same volume formula. They both rely on the concept of unwrapping the figure to produce the surfaces you're going to calculate. Their surfaces therefore must include two parts. We have the area of the two bases, so those are the two pieces that are parallel, and we have the lateral area. That's the part that wraps around. Well, the lateral area always unwraps to be a giant rectangle. And that giant rectangle, one side is equal to the perimeter or circumference of the base and times the height of your prism. It's the distance between the bases. So your lateral area is equal to perimeter times height. And your surface area is 2 times the area of the base, because they're two bases, plus perimeter times height. Or, when in doubt, just make a list of the surfaces and add them all together. Now, again, just like we talked about with our area formulas, we are going to follow a set of steps whenever we're using formula-heavy problems. And those steps are as follows. And that is, we're always going to write the formula, then we're going to list our variables, we're going to find capital letters, because capital letters always means we have to do more work to find that thing. It's not something that's actually in the problem. We're going to plug in for our variables, and we're going to solve with units. So let's take a look real quick at this first figure. This figure here is a hexagonal prism, which means that my bases are the two hexagons, and the lateral area would be equal to 6 rectangles. So I'm first going to list my formula. It's a prism, so surface area equals 2 times the area of the base plus perimeter of the base times height. So things I need a base. Well, that base is a regular polygon, so I'm going to use the area of a regular polygon formula, which, if we recall, is 1/2 perimeter times apothem. Well, that means I still need perimeter, which is, again, number of sides times side length. So I need my number of sides, and I need my side length, and I need an apothem. And then I also need perimeter, which I already have here, and the height of my figure, which is h. So let's go through and find all of these pieces. So my number of sides of the base is 6. It's a hexagon, so it's got 6 sides. And that side length, they tell me here, is 10.6. So I'm going to put in 10.6 for my side length. The apothem I'm given right here is 9.2. So we're going to write in 9.2 here. And then the height of the figure, the distance between the bases, is 33. Well, let's now go back up the ladder and fill things in. Well, perimeter is number of sides times side length. That'd be 6 times 10.6. Well, 6 times 10.6 gets me 63.6, which you can find in your calculator or by hand. And then my area of a polygon, 1/2 perimeter times apothem, that's 1/2. My perimeter is 63.6, and my apothem ends up being 9.2. And when I plug that in, I get 292.56. Well, now I'm ready to plug in to my original formula. So again, surface area equals 2 bases, that's 2 times 292.56, plus a perimeter, which is 63.6, times the height, which we found to be 33. Guys, if you want to, at that point, you can plug all that into your calculator straight away and it will produce the answer. Keep in mind, this piece right here is the lateral area. So if you're asked to find the lateral area, that's it right there. But when I plug this into my calculator, I end up getting 2,683.92, and I need to interpret in terms of units. Well, this is in kilometers squared. That's kind of a ridiculous unit, but there you go. That's how we would find the surface area of this. I'm going to erase this so I can work on the cylinder so I have some space. But let's take a look at the next piece then. So now we're going to do a cylinder. Well, area of a cylinder, surface area of a cylinder, is still 2 times the area of the base plus the lateral area, which is perimeter times height. Well, the area of the base in this case is in fact the area of a circle, because my base is a circle. Remember guys, base is not what it's sitting on, it's what you would name it after. If this is a cylinder, that means my bases are circles. So this guy would be area is pi r squared, which means I need to find the r, okay? Then my perimeter, in this case, perimeter is actually circumference, and circumference is found with 2 pi r. Well, we already have the r listed, so we're good there. And then I still need the height. So the height. Now let's fill in the variables we know. We know the height is 6. I know that my radius is 1, which means now I can find my capital letters. Well, circumference is 2 pi times r. That's 2 pi times 1, which is just 2 pi. And then my area of a circle is going to be pi times 1 squared, or just pi. So we've now plugged in, we found the capital letters, now we're going to plug in for the variables. So my surface area equals 2 times my base was pi, and plus perimeter was 2 pi, and my height is 6. So that works out, 2 times pi is just 2 pi, plus 2 pi times 6 is 12 pi, or I get 14 pi. My units here are in meters squared. All right, guys, let's take a look at the next section. Now we're going to talk about pyramids and cones. And like prisms and cylinders, pyramids and cones are incredibly similar. Notice they both come to a point. And so their formulas actually very much mimic each other. And our formula here, we only have one base this time and a lateral area. So my surface area equals base times the lateral area. And the lateral area is actually going to mimic that of a triangle, where my lateral area equals 1/2 perimeter or circumference times slant height. And guys, your slant height is always found from the top, from the vertex of your cone or pyramid down to the midpoint of the opposite side. This right here is your slant height. On the cone, it's right here. It's this segment right here. This here is your slant height. It's different than the height. The height is the difference from the base to the vertex. That's your height. Here and here, those guys would be the height. But for surface area, we want slant height. So your total surface area formula is surface area equals base plus 1/2 perimeter times slant height. So, oh, my arrow got off here. This should be pointing right here at the 5. Okay, so let's do a cone. Again, we're going to go through the same steps we were going through before. We start off by listing our formula. Surface area equals base plus 1/2 perimeter times slant height. And we list all of our variables. Well, the base is a circle, so I'm going to do the area of a circle, which is pi r squared. So I need to find r. 1/2, I need a perimeter. Well, perimeter in this time is a circle, or it's a base is a circle, so I need really circumference, which is 2 pi r. I need r, I've already listed r. And then I need my slant height. Well, let's fill in the things we know. I know the slant height is 13. I know the r is 5. So that means my perimeter, or my circumference, is 2 pi times 5, which is 10 pi. And I know my base area is pi r squared. That would be pi times 5 squared, or 25 pi. So I've now found all my capital letters. I'm ready to plug into my formula. Surface area equals area of the base is 25 pi plus 1/2 times my perimeter was 10 pi because it was a circumference times my slant height of 13. I start solving this out. I get surface area equals 25 pi plus 1/2 of 10 is 5. 5 times 13 is 65, which this becomes 90 pi. I actually don't have any units listed, so I'm just going to call this units squared. And that's how we find the surface area of a cone. Now let's do the pyramid. Guys, I'm going to again erase what's over here so I have some more space to work because my handwriting's really big when I use the stylus. But feel free to come over here and let's do the rest. All right, so let's talk about the pyramid. So the pyramid, again, we start off by listing the formula. surface area equals base plus 1/2 perimeter of the base times the slant height. So I need the base. Well, the base this time is a regular polygon. It's a pentagon. So we need its formula. That's 1/2 perimeter times apothem. Well, perimeter is number of sides times side length. So I need the number of sides and I need the side length. I also need an apothem. Coming back up, I already have perimeter listed. I also need slant height. So let's go through and fill all these things out. So slant height, oh, this is somewhat mismarked, guys. There should be a segment coming from here to here with an arrow pointing here. My little thing disappeared. But if I were to work this out with Pythagorean theorem, 8 squared plus 15 squared does in fact equal 17 squared. So I know that this is the slant height here. So my slant height is 17. I gave it to you on this. The apothem is 8. My side length is 11.6. My number of sides is 5. So working up, perimeter equals 5 times 11.6, because there are 5 sides, each at 11.6, which gets me 58 is my perimeter. And then here, my base area, I don't have space. I'm going to come down here to do base area. Base area is 1/2. My perimeter was 58 times my apothem, which is 8. When I work that out, I end up getting that my base area is 232 feet squared. Well, then, am I ready to plug in? I'm ready to plug in. So we say that my surface area equals the base area, which is 232, plus 1/2. My perimeter again is 58, and my slant height we said was 17. And that works out to surface area equals 232 plus 493, which equals 725 feet squared. And again, guys, if I were asking you for the lateral area, that 493 is the lateral area, whereas this right here is your base area. So you might have a question that asks you for one or the other, and that's where you pick them out. All right, moving right along, we're talking about volume, last but not least. So the volume of a prism or cylinder is exactly the same formula. Its volume equals base times height, where capital B still stands for area of the base. That has not changed. Okay. And just like before, oh, and by the way, this disappeared. It should say height equals 10 along here. Just like before, we're still going to follow the same order. We're always going to list out our formula first. Volume equals base times height, where the base is pi r squared, and we're going to find all of our variables. I need r and I need h. Well, they give me here that r is 3 and my height is 10. I just told you that. So I plug in for the area of the base. That's pi times 3 squared, which gets me 9 pi. And so my volume is 9 pi times 10, or 90 pi. I don't have units, so we're just going to call this units cubed. And we do the exact same thing over here. We are talking about volume equals base times height. I want to point out that this is the height of the solid, because we're also going to have a height of a triangle in here too, and they are two different pieces. So keep in mind that's height of the solid. Well, your base area here is actually the area of a triangle, because your base on this triangular prism is in fact that triangle. That's the base. It's what we name it after. It's not what it's resting on. It's what we name it after. So that's 1/2 segment length of the triangle, it is the base, times the height of the triangle. And again, this is different than capital B, and this height of the triangle is different than the height of the solid. So we have to keep those separate. So the variables we need that base segment length, we need the height of the triangle, and we need the height of the solid. Okay? So the height of the solid is the distance between the two bases. That's this 14.7 right here. It's the distance between the two bases, 14.7. Whereas the height of the triangle is this piece right here, it's how tall the triangle actually is. That's 6.2. And the base of the triangle is this 11.1, which we could recopy down here to 11.1. 11.1, okay? So now we're going to go through and solve. The area of this triangle, let's go ahead and work this out. The base area is going to be 1/2 times that 11.1 times 6.2, which works out to be 34.41 when you work it out. So now we can plug into volume because we have everything we need. So the volume equals area of the base, which is 34.41, times the height, which is the distance between the bases, which is that 14.7. So when I work it out, I get that the volume is in fact 505.827 millimeters cubed, because volume is cubed. Volume of a prism and a cone are incredibly similar to volume of a sphere, or sorry, not sphere, volume of a cylinder or a prism. You just multiply it by 1/3. So your volume is equal to 1/3 area of the base times the height. Again, you got to be careful. This is a height this time. Your height is always this piece right here. It's the straight vertical. And so you sometimes have to find the straight vertical by using Pythagorean theorem, because you notice you have lots of nice triangles here, lots of right triangles, like we're going to have to on this cone. But let's walk through 2 examples. I'm going as fast as I can, guys, I promise, so that y'all don't have to watch a super long video. Let's go through this pyramid together. So I want to do volume equals 1/3 area of the base times the height. Well, your base in this case is in fact a pentagon. So it's going to be the area of a regular polygon, as we've been doing a lot, which is 1/2 perimeter times apothem, which means we need a perimeter, which is the number of sides times the side length. So we need number of sides, and we need side length, and we need an apothem. And I also need a height. And if we find all these variables, we have everything we need for the problem. Well, the height is 15. The apothem, they tell me here, is 8. Your side length is 11.6. Your number of sides is 5. So this is 11.6 times 5, which actually works out to 58. So when I plug into the area of the base, it's 1/2 of 58 times an apothem of 8, which gets you 232 is the area of your base. So my volume is going to be 1/3 times that 232 times the height, which is 15. And when I work that out, I end up getting 1,160 feet cubed. And that's how we find the volume of a pyramid. Well, we got to do the volume of this cone too, so let's take a look at it. Well, first things first, I'm missing this height, right? So I know with Pythagorean theorem that h squared plus that 5 squared must equal 13 squared. Should be a square there. So I get h squared plus 25 equals 169. So my height squared equals 144. So the height itself must be 12. So we're going to need that in our problem. Well, again, we have area equals 1/3 area of the base times the height. Well, my base is a circle, area of a circle, which equals pi r squared. So I need r. Well, r is 5. I also need a height, which we already found is 12. I don't think any other variables than that. It's pretty easy. So I plug in. This becomes pi times 5 squared, or 25 pi. Plug in back up here. I've got 1/3 times 25 pi times 12. Sorry, I thought I had enough space. I don't. So my area, 1/3 of 12 is 4 times 25 gets you 100 pi. And we don't have any units, so this is just units cubed. And we're done. All right, guys, thank you so much. Take a look at the MML, and that's surface area and volume.